Before we proceed further, let us recollect the integrator which we saw in the previous video. The action of integrator was explained there. But when we talk about digital control of any system, we attain the digital control by using a digital controller or a microcontroller. But all that a microcontroller do should be known to us first. Then we will see how to leverage it to obtain the control which is required for your particular application. So here we need to first understand what are the capabilities of a microcontroller, what are the capabilities of a digital microcontroller. So what we have in screen is just a very high level view of any microcomputer or microcontroller. So we have just two things. One is a processing unit and the other is a memory unit. The memory unit is a place where you store data and you retrieve data from. And the processing unit is the place where you operate on those two data. For example, 2 is a data, 5 is a data. So those two will be stored in the memory unit. If I wish to add those two, the addition operation will take place in the processor, or it will take place in the processing unit. So this is all about any digital microcontroller in the world. So the capabilities of a microcontroller could be simply drafted in the form of a tabular column. So there's a need to store data and to operate on those. So how is this need met on the hardware level? How is it met on the physical world? And how is it met in the software level? So we need to understand these first. So the provision to store data is a need, and that need, as we saw earlier, in the hardware level is met by the memory unit. And the provision to operate on them is achieved by using the processing unit, or simply your CPU. Now, on the other hand, if you move to the software side of this, then the provision to store data, like whatever you are storing in your memory unit, are basically nothing but variables in your code, because these variables will store the address of that memory location. So these variables, so that's the fundamental definition of a variable. So these variables handle the memory in the software level, and any provision to operate on them is basically achieved with the help of operators. So what do we mean to say by this? Assume that this is all my microcontroller to do. In fact, this is all any microcontroller could do. This is what we got in our hand now, and we have to make use of this wonderful piece to control any plant. And in our case, the plant is going to be a DC-DC converter. So the controller, the integral controller, or the proportional integral controller, or the proportional integral differential controller should be realized using this microcontroller, which has only these two capabilities. So what is the challenge we are facing here? The challenge we are facing here is conversion of a controller which is in the form of some Ki by S or Kp plus Ki by S, which we have in a continuous domain, into something which a microcomputer can understand. And it can understand only variables and operators. So what we do is we use variables and operators. Say for example, this will be my variable 1 plus variable 2 minus variable 3 into variable 4 divided by variable 5. So what am I doing here? All these, let this be assigned to another variable, maybe variable 6. So what am I doing here? I am writing a simple equation which uses all the variables which are implemented in the memory unit in the hardware. And it makes use of all operators which are taken care by the CPU. Whatever operation you are mentioning here is fundamentally taken care by the CPU. So you are using this memory unit as variables, or you are enabling the use of memory unit through variables, and you are enabling the use of processor through operators, and all you can do is form an equation which the computer can compute now. It can compute all these values, can add or subtract or multiply or divide or do something, and it can compute all these values, and it can give you a number again. Now this number has to be meaningful to you so that you can deploy this in your system. So this equation, this whatever equation you call, should basically represent or realize your controller. In the case of an integral controller or proportional integral controller or any PID controller, we call this equation as a difference equation. So your ultimate aim is to arrive at a difference equation which will represent your Kp plus Ki upon S, which will represent this into a combination of addition, subtraction, multiplication, division, so that your computer can be programmed easily using variables and operators, is called a difference equation. Now the question is how to obtain this difference equation, which we will be discussing in the next video.